Hey, welcome to InnoThinker. Today we are here with a repair project. Ever struggled with a memory card reader that doesn't work properly with some of your cards? You are not alone. Today we are diving into a solution by repairing a memory card reader that's giving us trouble. Join us as we tackle this widespread problem. This Sony MRW-G2 card reader right here in front of me is perfect for photographers and videographers, supporting both SD cards and CFexpress Type A cards with lightning-fast data transfer rates. This memory card reader has a bit of a hiccup. It reads SD card just fine, but it seems to be struggling with CFexpress memory cards. Okay, let's disassemble it to find the problem. First, I open the front part using the spudger. Underneath, there are two screws. Remove them and take off the next part with a spudger. It's a little challenging, so do it gently. Now you can see the PCB. Push it slightly from the SD card side. Be careful not to damage the SD card connector and PCB. This is the SD card connector. This is a single connector for both SD and CFexpress cards. The top pins are for SD cards and the bottom pins are for CFexpress Type A cards. If you fill up the PCB, you can see these two thermal pads. It's better to remove them if you want to heat up the PCB. Let's take a quick look at the PCB components. Here there are three ICs. This one is for reading SD cards. The next one is for reading CFexpress Type A cards. Near each IC you can see the voltage regulator. The third IC is the USB-C bridge. There are also three E2 corresponding to these ICs. Now I'm going to check the connector under the microscope. I visually inspected the connector and the pins were intact, so the problem is likely not with the connector. The next part that is most likely to be faulty is the CFexpress bridge IC. The part number is JMS583. First, we need to check if the power pins of the IC are receiving voltage. Pin number 16 should have a voltage of 5 volts, and the pin number 31 should have a voltage of 1 volt. Note that on most PCBs, the connector shields and polygons are grounded, and you can use them to measure voltage. We have 5 volt at pin 16. Also, we have 1 volt at pin 31. So, we don't have any issue with the power of the JMS583. In the next step, we need to check if the IC is functioning properly or not. To do this, we first check the clock of the IC. As an example, I first examine the SDIC. This IC is functioning properly and shows a 25 MHz clock. Now let's check the clock of the JMS583. As you can see, there is no clock signal. So the IC is faulty and the X out pin is not providing any output. Let's go ahead and replace it. I turn on the hot air station, setting the temperature to around 300 degrees. First we preheat the PCB. Then we add flux to the board. This helps the flux melt evenly on the PCB. Don't forget to add more flux if needed. Here I have the spare part. Let's go ahead and place it. After removing the IC, if the solder on the pad is good, there is no need to add more solder. Make sure the solder on the center pad is not too thick or too thin. Here the solder has accumulated in one corner of the pad. Using the soldering iron, spread the solder evenly across the entire surface of the pad. Since this pad is ground, if your soldering iron doesn't provide enough heat to melt the solder, you can first apply some heat to the pad with a hot air station. Now replace the new IC. At the first, apply some flux. Now place the IC in its position and heat it with a hot air. To test, gently tap the IC with the tip of the tweezers. If the IC returns to its place, it has been heated sufficiently. Inspect the pins around the IC. If any of them are not soldered properly, solder them. So clean the board, apply flux again, and then use the soldering iron with a small amount of solder wire to solder the necessary pins. You can use hot air to dry board after cleaning. All the pins have been soldered. Before we test the device, if you're enjoying this video, please hit that like button and subscribe to the channel. Your support means a lot. We made it. The computer successfully recognized the device. Let's reassemble the device. Don't forget to attach silicone pads to the back of the PCB. That's it for today's video. We successfully fixed the memory card reader and it's now fully functional. If you have any question, feel free to ask in the comments below. Thanks for joining us on this journey. See you in the next video.